Okay, this is Algebra 1, Lesson 11.5, Solving Rational Equations. So we learn how to simplify rational numbers. We learn how to add them, subtract them, multiply, divide them, and all leading up to solving rational equations. So in this lesson, we're going to solve rational equations and proportions. So what's the solution of this equation here? So what we need to do is get rid of our fraction. So we need to be able first to subtract these, right? In order to get rid of the fraction. So to do that, what we're going to do, and we're also going to use this side too, is find the least common multiple of the denominators of each fraction or rational number that's in our equation, so that we can, actually, if we make it all the same, then we only care about the numerators. So let me show you how this works. So we can see between 12 and x, right? The LCM is obviously going to be 12x, right? Because, right, you take one of them, right, and then anything that's not included in the other one, you need to add. So it's just 12x is going to be our LCM. So this guy needs an x, which means we need to give that an x, and then this needs a 12, which means that needs a 12, and then this one needs a 12, and that needs a 12. So this is going to be 5x over 12x minus 48 over 12x equals 12 over 12x. Now we can actually, just the numerators are going to matter now, because what we can do technically is multiply everything by the bottom. This is kind of like fraction busting by the bottom, or the numerator times 12x times 12x, right? Distribute that there. 12x divided by 12x becomes 1, so this is just 5x. 12x divided by 12x just goes to 1, times 48 is just 48, so minus 48, and then, right, those go to 1 also. So once you have all the denominators the same, right, the bottom is called the denominator, then that means you can get rid of it, and you only care about the tops, or the numerators. So then once we do that, we have a very beautiful equation to solve, where we just add 48 to both sides. That goes to 0, so 5x, and then divide by 5, so x is 12. And then we can just see here, right, if we just plug this in, right, 5 over, from our original equation, 5 over 12 minus 4 over 12 equals 1 over 12, right? 5 minus 4 is 1, 12. And that works, so x is 12. All right, so that was a nice, simple example of how to solve an equation. So try this next one on your own. What's the solution of each equation? You can actually try both of these. Let's start with this one, and then let's go over it, and then you can try B second. So press pause, try this on your own, and then check back for the solution. Okay, hopefully you got, I didn't circle it. X equals -3. LCM was 3x. Distribute it, make them all the same, and then distribute it so they all cancel. So you just have the numerators, and then solve, and you can check too. Okay, now try B. Press pause and try this on your own. Check back for the solution. Okay, that one was a little bit annoying. Just the checking part. You don't have to check these, but it does help to make sure you got the answer right. 37 over 7 was the answer. And the decimal, it didn't say, I prefer you to leave it in fractions, because it didn't say to leave it in round or anything, but 37 divided by 7 is 5.2857 ... But leave it in the fraction. And so you can see our LCM was 21x. So if you made all three denominators 21x, you only have to care about the tops or the numerators. So 12 plus 7x equals 49. Subtract 12 from both sides to get 37, and then divide by 7. And then I checked it, and it does work. The checking was a little bit fraction heavy, but it's good practice. Okay, let's move on to problem 2. These are just going to get slightly harder. But this is multiple choice. So what you could do for this is just plug them in. But let's not do that. Let's do what we just learned. So here, where this is over 1, our LCM, we have, well, 1 is always there, right? So we can multiply that by whatever we get. We have an x here, an x squared. Since there's already one x, we need one more x. So x squared is going to be our LCM. So we're going to use multiply this by x squared. That one needs an x squared. This one only needs an x, and this one doesn't need anything. So this is going to be x squared minus x equals 12. Okay, and we're just taking the numerators, right? Because the bottom is x squared, the denominator is x squared, x squared, x squared. So here we see that this is quadratic, so we're going to keep our x squared on this side. We're going to subtract 12 from that side, and then both sides. So this becomes x squared minus x minus 12 equals 0. And then we're going to factor this. Let's look for two numbers that multiply to negative 12 and add to negative 1, which are negative 4 and 3. So this becomes x minus 4, x plus 3, that equals 0. This is 0 when x is 4. This is 0 when x is negative 3. And we don't have to check it because we have multiple choice, so that would be our answer there. That would help to just know that you did it right. You can check it, but I won't put you through that right now. Okay, let's move on. So try these. Let's try A on your own. Press pause and check back for the solution. Okay, this one's a little tricky. It had some fun factoring in it, but hopefully you got y equals negative 3 divided by 2, and or negative 3 over 2 and then 2/3. So if you didn't, press pause and take a look at my solutions. See if you have any questions. Over here I did add the 6y to this side because I want it to be positive, your x or y squared term to be positive. Since it's negative here, that really throws off our factoring. So that's why I added it and went to this side. Okay. Now why don't you try B? Press pause for this, and then check back for the solution. See if you can figure this one out. It's a little bit different. Okay, hopefully you got d equals negative 7, and d could be negative 1. And for this one, you just needed to get rid of the denominator here by multiplying both sides by d plus 3. So then those go to 1, so they go away, and then d plus 11 stays on this side, and then you have this here where you can FOIL, simplify, and then get one of these sides to 0. Since my d squared term is positive on this side, I want to get rid of this, make this side 0, minus d minus 11, and then factor, an easy factor, and then solve. Okay, problem 3. Amy can paint a loft apartment in 7 hours. Jeremy can paint a loft apartment in the same size in 9 hours. If they work together, how long will it take them to paint a third loft apartment of the same size? Okay, so what we're going to do here is compare, put them in like terms. So we're going to just say how much of the apartment can each one of them do in 1 hour, right? So if Amy can do a whole apartment in 7 hours, she can do 1/7 of the apartment in 1 hour. Okay, and then Jeremy can do, in that same hour, he can only do 1/9 of it. But if they're doing that together, right, you can figure out what their work is together by solving for this x. Does that make sense, right? How many, like one apartment in how many hours together if we added them together? If she does this, she's this fast and he's that fast. Okay, so then what we need to do is figure out our LCM. So our LCM here is, let's start with 7. 7 is prime. 7 is not included in 9 or x, so we need a 9 for this one. And then we need an x, so we just multiply everything together. That is 63x. So this guy gets a 9x. This guy gets a 7x. And this guy gets a 63. So now all the denominators are the same. Our numerators are 9x plus 7x equals 63. So 9 plus 7 is 16x. And then you just have to divide 63 by 16. And you get about, what is this, like 3.94. And how long will it take? So about 4 hours, right? You can say that. Okay. so let's move on to the next page. There's going to be one for you to try on your own. One hose can fill a pool in 12 hours. Another hose can fill the same pool in 8 hours. How long will it take for both hoses to fill the pool together? Press pause, try this on your own, and then check back for the solution. Okay, hopefully you got 4.8 hours. So you just need to find the LCM of 24x, make the denominators all 24x, and then just deal with the numerators and solve for x, 4.8 hours. Okay, and then problem 4, is that not the end there? This is going to be a proportion. So here we can just do cross multiply. This shouldn't be too bad, right? 4, and just remember your parentheses. 4 times x plus 1 equals 3 times x plus 2. So if we distribute this, we get 4x plus 4. And this is 3x plus 6. So if we subtract 3x from both sides, we get x plus 4 equals 6. So x equals 2. And let's just, this was one we can check. 4 over 4. Does that equal 3 over 3? 1 equals 1, yes. So x equals 2. Okay, so it's proportions just like cross multiplying. I think we even did ones like this when we did proportions. So hopefully this isn't too bad for you. Let's try A, press pause, try that on your own, and then check back for the solution. Okay, hopefully you got B equals -8. If not, press pause, try to figure out what you did wrong. Email me if you still have questions. And then try B on your own. Press pause and check back for the solution. Okay, hopefully you got -3 for C. Okay, last page. All right, one more. This, I think, it does say to check your solution. So I think we're gonna, it's extra important when it's asking you to look for extraneous solutions. I have a feeling here that we might have an extraneous solution, but let's do our cross multiplying. 6 times x plus 5 equals x plus 5 times x plus 3. If we distribute on this side, 6x plus 30 equals x squared plus 5x plus 3x plus 15. And then combine like terms. And then this is my positive x squared term. So let's move everything over to that side and get 0 on that side. So this becomes x squared plus 2x minus 15. So two numbers that multiply to -15 add to 2 would be 5 minus 3. Okay, so this becomes x plus 5 times x minus 3. This is 0 when x equals -5. This is 0 when x equals 3. So we have two solutions. Let's check each one to make sure we don't have an extraneous solution from our original. So 6, -5 plus 5. Oh, here we can already see, right, this is 6 over 0. So x equals -5 cannot be a solution because the denominator equals 0. And we cannot divide by 0. So it cannot be x equals -5. And now let's check 3. So 6 over 8. Does that equal 3 plus 3 is 6? 3 plus 5 is 8. Yes, it does. So x equals 3 is our only solution. Okay, so try this one on your own. Press pause and check back for the solution. Okay, hopefully you got x equals 0 and that x equals 2 was your extraneous solution, because you can see here when you plug in 2 into this denominator, 2 squared is 4, 4 minus 4 is 0, so you cannot divide by 0. So there's an extraneous solution, and this one works here. So if you made a mistake or didn't get that answer, press pause and then look at my solution, see if you can figure it out. If not, email me, let me know if you have any questions, please. Again, email me. And here is your practice for this section. All right, enjoy.